Let me welcome all of our attendees, all of our delegates to the final day of the first week of the GSE UK Virtual Conference 2021. It gives me great pleasure to introduce old friends Rob Gould and Gareth Coppleton-Jones, although they're not that old. I do feel much older.
Quite old. I'm old.
And boy, have they got a good presentation for you today. APPLCOMPAT, NULLID and Me. This is session 7 a.m. So it feels like 7 a.m. But I can assure you that it's not. Please fill in your feedback forms at the end of the session, because that will enable us to provide you better content in years to come. Also, please don't forget the sponsored charities for GSE this year are Lifeboats and Guide Dogs for the Blind. Let me hand over to our esteemed speakers.
Good morning, everybody.
Good morning. After you, Ralph.
Sorry, yeah, good morning, everybody. So just very briefly, Rob and I both work for Triton Consulting now. So I don't think there's much more to be said. Rob's going to lead the first half of this presentation. If you want to raise a question, just raise your hand on Zoom, and we'll be tracking to see who's raised their hand, and then we'll unmute you and you can answer your question. But we do encourage you to ask questions as we go along. This is in some ways, a fairly complex topic. But over to you, Rob.
Right, thank you very much. So, morning, everybody. So, Gareth, you can click the slides on, please. So, again, this is the lifeboats and the guide dogs. So, please give generously. We'll kick over again. So this is the agenda. We've got just a review of what it does, to be honest. Just, you probably already know this, but we'll cover it. And then we'll go through a bit about how it works with continuous delivery, because it's changed slightly from version 11. How do you go about exploiting the new stuff, which is interesting. And then bind, rebind, what that does, the current application compatibility special register, and then when we'd like to bind and rebind. So that'll finish my bit, and the rest of the bits are in grey, and that's what Gareth's going to cover. So that's, how you're actually going to manage it and what we're going to do with the null ID stuff and sorts of bits and pieces. It gets quite complicated after there, which is why I'm doing the first bit, obviously. Right, off we crack. So managing APPLCOMPAT, an overview. So this is just a picture slide, really. So we've got APPLCOMPAT in the middle. Static SQL, you could bind with your APPLCOMPAT bind parm, and then you pick a function level, so that's not too tricky. And then you've got dynamic DBA developer package over on the right hand side, and for those you can set your current application compatibility special register when you run your program, so that's not too difficult either. But then you get to the generic, what happens when you throw dynamic SQL just into DB2? What does it run as? Which packages does it pick? So that's where it gets quite messy. So here we go. This is a bit more in depth, but you probably know most of this already. So APPLCOMPAT introduced at DB211 for ZOS. Basically, so you could avoid fixing any problems if, it was to get rid of all the prereq stuff. Most of the prereq stuff had to do with SQL before you could actually upgrade. So effectively, it gave you a shortcut. Instead of doing all the prereqs like we've done in all the previous releases, you could put version 11 in and you could ignore the SQL compatibilities, and you could set APPLCOMPAT and just carry on your merry way. So the way you did this was you had the special register that you could set when you run programs, and you had the APPLCOMPAT bind option. So obviously these operate at the package level for the bind rebind. That's fairly obvious. The current application compatibility special register, which I'm just going to call the special register from now on because it's a bit of a mouthful. So that overrides the AppleCompat saying. So it doesn't matter what you banged it as, you can change it when you actually run it. If anybody's run the prereq stuff, you'll know all about the ifseds to capture and report on the application stuff. I think most of us have run those one time or other. So DB211 included support for AppleCompat back to version 10, or you could just run version 11 as was really. So that was what the V11R1 was for. At the time, they said that they'd support 3 releases. So version 12 would support 10, 11, and 12. It got a bit more complicated towards version 12, as you could say, because version 12 supports function levels now. So you can go function level, 100, which isn't really version 12 at all. Function level 500, function level 501, and still comports AppleCompat version 1001. So you could still run version 10 stuff in version 12, which, swings and roundabouts. Probably be nice to actually run some version 12 stuff in version 12. It includes SQL, DDL, and DCL compatibilities, as well as the DML and XML. Version 11, I think, was only DML and XML. So that's that bit. Continuous delivery, where AppleCompat fits in. So there's 4 levels associated. Again, you'll probably know this stuff, but it's worth going back over. Maintenance levels, obviously, we call that the DB2 code level as was. So that's the level of fixes you've actually got applied on your binaries. So we know what that one is. So the next bit is catalog level. On the cat mates, as we used to run them on an upgrade, now you have to run them in function levels. That's interesting, kind of. You need to run them for some function levels and not for others. So I think 503 has got a cat mate in it off the top of my head of version 12. So that's good. So we're happy with that. And then this is where it gets a bit messy. We've got the compatibility level. I'm sure Gareth's desperately pressing buttons at this point. There we go. So AppleCompat set the package level again, providing an island of scalability, which is a nice term for a given application. So it determines the SQL function level of the application. You must advance it if you want to advance it by a bind or rebind, if you want to exploit new function. AppleCompat, it's got to be less than or equal to the function level. That makes perfect sense. You can't have one that's higher than the function level. It's pretty obvious. Freezes new SQL syntax, even if an earlier function level is later activated. And the ZParm provides the default for bind, add, replace. So if you don't specify AppleCompat and a level in your bind parms, then it will take the one out of ZParm. BIF compatibility remains the same. So all your case and cast statements won't be affected by AppleCompat at all. So that's that bit. This is just a picture. So this is good. So here we are. We've got a maintenance level of 504. So that means for a catalog level, we need to have a catalog at least 503. So we've done the 503 cat mate, so that's good. Function level, then we moved up to 503, so that's happy as well. And then at the end, you've got your AppleCompat stuff. So you can now bind stuff using AppleCompat at 503. No need to change the AppleCompat ZParm. So the ZParm just says 501. If you don't put the AppleCompat parm in, it'll bind it at 501. If you do, it'll bind it at 503. So that's that stuff. So bind, rebind, and the current application compatibility special register. Bind replace does not reuse any bind option for the existing package that is not explicitly specified. Can't say that. So basically, if you want it to be taken into account, you have to actually tell it in the bind. SQL statements can be totally different. So bind replace is considered a new bind. So that's fine. So that'll ignore anything that's already in there. Bind replace add will use the ZParm value if you don't actually stick it in the bind. So that makes sense as well. Rebind and bind copy will just do what they say. So they will reuse the existing packet options if you don't specify something different, or if you don't specify something specifically. So you're going to need the AppleCompat column insys package to contain a valid value, or if not, it's going to use the one in the zip file. So again, that's fairly straightforward. The current application compatibility register allows you to override the AppleCompat level that the program runs at execution time. We know that. So for version 11 for ZOS, the value can be greater than or equal to the AppleCompat level of the package already, but not greater than the DB2 current version. Again, that makes sense. DB212 for ZOS, value has to be less than or equal to the AppleCompat level of the executing package, independent of the current DB2 function level. So you'd have to rebind it if you wanted a higher value. That's basically what it's saying. So yeah. When would you rebind with a higher application compact value? Well, once you've eliminated all of the incompatibilities for a given package. Obviously, if you've eliminated all of them anyway, and you don't want to exploit any new functionality and the support's still there, why would you bother, to be honest? Because you never know, you don't really want to rebind unless you've absolutely got to. But, you know, once you've got everything sorted, you want to exploit new functionality or IBM has withdrawn support, then rebind your static packages. That makes perfect sense. We're happy with that. Dynamic stuff. Again, if you expand to exploit new DDL capabilities, or you plan to test or evaluate the new SQL stuff, you can use the current application compatibility special register, or you can use different package sets even if you want to maintain application compatibility. So you can have two packages and different package sets to, you know, and you run the new one to test the new stuff, and you can always fail back to the old ones if you want to use them. Generic dynamic SQL packages. This is where it gets messy. So that's why we've got a big red flag. So how do you cope with that? So that's my bit, I think.
Oh, hang on.
That's the same one again.
Hey. So let's just move on to the next part. And then I'm going to skip through this part, which is what Rob's just talked about, all the important background information. Oh, Paul, okay. Paul has a question. There we go. Paul, go ahead.
Can you hear me okay?
Hi, Paul. Good to see you. Good to hear from you. How are you?
Good, thank you. Question for probably Rob. We might cover this later, I'm not sure. You've not yet talked about regression from function levels. So scenario is if I've activated 501, done a bind because someone wants to use the list ag function with AppleCompat 501 in the bind cards, and we decide we need to fall back to M500 star. Now I know that package will still execute with list ag function in, even though we've gone back to 500 star. If I try and rebind that package and the bind cards had AppleCompat 501, what's going to happen?
That's a really good question. And
that's why I asked it.
That's a really good question. And I think the rebind will work, right? Because of that sticky option, and you're not changing the SQL.
Yeah.
All you're doing is rebinding an existing package to get a new access path, presumably, or for some other reason to fix a bug. But that's a good question. I don't have a definitive answer. Do you, Rob?
No, I think. I'm not sure, to be honest. I think it might break. I'd have to try it. I think we should try it. Yeah. Well, we'll let you know, Paul.
Okay. Let me know when I see you next month. Yeah, we've only just gone to 500 in Sandbox, so I can't try it just yet. But thank you, gents.
Thank you for asking a question.
That's my pleasure.
Cheers, Paul. Good one. Good one. Okay, so Rob's covered all of that information, the background information about APPLCOMPAT. But in this session, we're going to talk about APPLCOMPAT and the null ID packages and essentially how you manage those. One of the things we're going to look at, in fact, the main topic of the conversation is going to be around the idea of multiple null ID collections. So you can have different APPLCOMPAT levels for different collections. And within that, we're going to look at client-side configuration, how you exploit those multiple null ID collections through client-side configuration, and also through as an alternative, through server-side configuration. And as part of that, we're going to look at system monitoring profiles in a little bit of detail. And as part of that, very important part of that, we're going to talk about the client information fields, which is part of the solution, but for many people is also part of the problem. And then we're just going to have a quick conclusion to review the options that are open to you. And just a brief recommendation for progressing forwards. So let's just talk about APPLCOMPAT and the null ID packages. So those null ID packages are essentially shared packages. They're generic packages used by client applications, such as those coming in using JDBC, ODBC, CLI, .NET, and so on. And they're accessing DB2 data via DRDA over TCP/IP. And they have a series of package names, sys something, 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 sys SN something, something, as you can see on the screen. Now for those, S indicates a small package, a small cursor size essentially. H indicates that you're using a cursor with hold. N indicates you're not using cursor with hold. And the X tells you the isolation level. So 1 indicates you're running with UR, 2 with cursor stability, 3 with RS, and 4 with RR. And then the YY, they're simply just sequential numbers that increase depending upon the availability of packages. So you don't really want to worry about the YY numbers. The important ones are the H and the X. So in terms of bind time and rebinding those null ID packages, why not just rebind the null ID packages with a higher APPLCOMPAT? And the reason for that is because those packages are generic and shared, you'd actually have to fix all application incompatibilities in all application programs that use them. So for most people, that really isn't a viable option. So the next question is, why not fix that at runtime by using the current application compatibility special register? Well, the reason for that is, and Rob's already covered this, is that in DB212, current application compatibility must be less than or equal to the bind APPLCOMPAT setting. So for you to be able to raise the APPLCOMPAT level, what you'd have to do is to rebind the null ID packages with the highest possible APPLCOMPAT level you wanted, and then you'd have to modify all the ones that you haven't fixed yet to use a lower APPLCOMPAT level, which is not a very attractive proposition. So really, what are the choices for managing APPLCOMPAT for those null ID packages? Well, the first of those is obviously not recommended, because, as we've said, that special register must be less than or equal to the package APPLCOMPAT. So we've covered that issue already. Now, the next option is, in general terms, is client-side configuration. And essentially what you need to do for that is to bind copy the null ID packages into multiple collections or package sets. Now, to do that, what you need to do is to have one collection per application compatibility level that you're going to exploit. And then what you need to do at the client side is set up one data source per required application compatibility per client. And then on top of that, assign the application to the data source, direct the application to the data source via client-side configuration. So that's quite a complex process. Now, the alternative is server-side configuration. And again, that requires binding the null ID packages into multiple collections, one collection per required application compatibility level. And the alternative for client-side configuration in this case is to assign those packages to the applications via system monitoring profiles. And that's what we mean when we say server-side configuration. Did I say, yeah, via system monitoring profiles. So let's talk about those multiple collections from null ID packages a little bit. And those are already used by some sites. For example, for managing the keep dynamic attribute, and for example, for high performance DBATs. And for high performance DBATs, you'd need to have those nullity packages bound with release deallocate, and then you'd have to modify DDF to say you wanted to use the bind option instead of doing release deallocate, which is the default for DDF applications. So some people already use multiple collections, and essentially the way you do it is in that string there you can see in the second bullet point, bind package specifying the new collection ID, and then you copy the null ID packages in and specify the new APPLCOMPAT level. Bear in mind, of course, that the APPLCOMPAT level must be less than or equal to the current function level. So you'd have to do that on a package by package basis because there are no wildcard options for bind copy. So you've got to do a specific bind for each package, but there aren't many of them, so it's not a particularly onerous task. Now, obviously the thing is, what you want to be able to easily do is to identify from those collections what the APPLCOMPAT level is. So you should use meaningful collection names such as null ID underscore V12R1 M504. And you've got an example bind copy statement there below it. Now, that does create a possible administrative difficulty for you, because you could end up with many null ID-like collections if you've got many attribute combinations. For example, if you're using APPLCOMPAT, Keep Dynamic, and High Performance DBATs with many combinations, you've got the administrative challenge of looking after a large number of collections and making sure you point applications to the right collection or package set. Now, you can as we'll see later, and this is an important point, and in fact, all the options of doing this use one or the other of these options. You can specify which collection and which package set you're using by the current package set or current package path special registers. Now, by default, those special registers are blank strings by default, and that means that they actually have no value. So it means that the current package set or current package path is the default one. Now, if you specify both of them, then current package path actually takes precedence over current package set. So let's move on to look at client-side configuration. And this is actually a massive topic in its own right. Setting those data server driver, data server client properties is really too big a topic to go into detail here, because you've got many options for setting those. But you can set them as JDBC properties and CLI ODBC properties. The names are pretty similar. It's just that the JDBC ones begin with a lowercase letter and the CLI ODBC ones begin with a capital letter. And there are a number of ways you can do that. You can specify those in your application program in the connection string. And there's an obvious problem with that, and that is going to require the number of application programming changes you're going to have to make, and it's going to give you quite a significant application testing effort to make sure that everything is specified correctly. Then the other option is via the data server driver, data server client properties, for example, through the db2cli.ini file and so on, through WAS, WebSphere application server, data source properties and so on. Now, the big problem with this is that it's a big administrative challenge when you've got many clients and many applications to configure. And quite probably, it's not you as DB2 database administrators who are going to be responsible for configuring those clients. They're probably going to be different people who are responsible for that configuration. So you've got a lot of people to locate and communicate with. And then you've got a massive effort in terms of change management, coordination and implementation. You've got a lot of testing because you want to make sure that they've done it correctly. Now, it's not saying that it can't be done. That does work for some sites, but it's more of a challenge for other sites. But in general, I regard that as a challenge to maintain going forward, especially as new applications are introduced, and they all have to be configured at the client end. So the big alternative we're going to look at is server-side configuration. Now, server-side configuration is achieved through specifying the current package path special register using system profile monitoring. Now, according to the DB212 documentation, system profiles don't support the current package set special register. So the only way to do it is via configuring current package path. Now, system monitoring profiles were introduced in DB2 version 9 quite a long time ago now, and they were enhanced in all subsequent releases. And those are configured via two profile tables. They're not catalog tables, and they have a number of supporting objects, such as the history tables, and we'll talk a little bit about the history tables in a minute, and indexes. So sysibm.dsn profile table defines the filtering scopes, who, in terms of an auth ID, or what is being monitored. And sysibm.dsn profile attributes defines the actions applied to what's being monitored. And you can obviously use this now in DB212 for setting the APPLCOMPAT level. Now, in terms of those system monitoring profiles, they're operated by DB2 command. There's the start profile command, which starts them, and you can have that automated at DB2 startup. And then there's the stop profile command. And I think I mentioned this later on, but the start profile command can be issued multiple times. So if you change the profile tables, you can bring in the new configuration simply by issuing the start profile command, and that refreshes that information. So let's have a look at the profile table. So, and there is more information on the following slides on defining filtering profiles, but each row, every single row in the profile table defines one filtering scope for a given profile. You can have multiple filtering scopes for a given profile, but only very limited filtering combinations are allowed. And we go into that on the next slide. Now, the next important point is, well, let me talk a little bit about the profile ID. When you issue the start profile command, there are no options on there to tell you which profile to start, which profile ID to start. You either start profile monitoring or you stop it. So the important thing here is the profile enabled column indicates to DB2 whether or not to activate that profile when monitoring is started or modified. And the default value for the profile enabled column is Y. So by default, if you insert a row into here and don't specify a value for profile enabled, that will be started. Now, you've got to be very careful when creating multiple profiles in the same filtering scope or categories that a thread or connection could match on. Right, you can create multiple profiles that an application could match on when it connects to DB2 because you've specified multiple scopes or categories that it could match on. So you're going to be very careful when you do that, because you have to be aware of the DB2 rules for applying multiple matching profiles and also the order of precedence. And we're going to cover that on the next slide. Now, I'm going to upload this presentation, and the DB2 rules, there's a link to the DB2 rules for applying multiple matching profiles and the order of precedence. But the point is that if you've got overlapping criteria, DB2 applies all profiles from different filtering categories with overlapping criteria. And then it uses the rules or order of precedence to decide which one wins. So yeah, so just a quick remark about the order. Well, we'll come on to that later, I hope. Okay. So yeah, we do. So each row in the profile table, that's the first important point, defines a single profile with a unique identifier in column profile ID. So that must be unique. And we're going to restrict this discussion onto the onto setting special registers, which is what you need to do when you're directing applications to a particular APPLCOMPAT level. So only one of the following profile categories can be specified for each profile. So in other words, when you create a row, insert a row, you must insert a row that has a value in the location column only, or a row that has a product ID value only, such as SQL for DB2 for LUW, HTTP or HTS for DB2 native REST services, P being without security, H being with effectively HTTPS, or you can specify auth ID role or both, call ID, package name or both, or one of client application name, client user ID, and client workstation name. So you can only specify one of those. And if you do that, then you have to follow the order of precedence. And that is quite complex, as you can see. And it's not just a simple case of saying where you've got two possible filtering profiles that an application could match on, which column takes precedence. It also depends on the value in that column. So for example, you can see at the very top, if there's an IP address or domain name in the location column, if you've got two that this filtering profile that the application could match on, that takes precedence. So that rules. But then you've got some other options below that, such as product identifier, role, and auth ID, for example. And then, in fact, if you've then got a server location name, a location alias or database name in the location name, that takes lower precedence than role and auth ID. So you can see that the rules of precedence are quite complex. So you have to be very careful. And then most importantly for this discussion, client application name, user ID, and workstation name take the lowest precedence of all. So that means that really you should choose one method of identifying the applications where possible, especially if you're planning to use client application name, user ID, or workstation name, because those will always take lowest precedence. So that's the tricky part of setting this up, or one of the tricky parts in setting this up. So let's move on to DSN profile attributes. Now, each row in DSN profile attributes specifies an action that you want to take when a thread or connection matches a profile in sysibm.dsn profile table. And in this case, profile ID is a foreign key that matches on DSN profile. So DSN profile is the parent, and that is defined with delete cascade. So if you delete a row with a profile ID from DSN profile table, all the matching profile IDs in DSN profile attributes will be deleted. And then if we're going to specify current package path for APPLCOMPAT reasons, the keywords column must contain the string special register, and attribute one, the attribute one column should contain the string set current package path equals with a comma separated list of collection IDs. So you can see that's quite a large varchar string, so you can fit everything in you need to fit in there, or should be able to do that. It's 1K long. And if you're specifying that string of collection IDs, the strings sysIBM and session user don't have to be, in fact, you shouldn't quote them, but any other collection IDs do have to be quoted in that set current package path string. So let's talk a little bit about the profile history tables, and those are quite important because they contain some useful information. And despite the name, they're not actually temporal tables. So they're both updated by the start profile command. That's whether or not you're starting system profile monitoring or refreshing it. And they contain a record of which profiles were active and when they were activated. So they contain more or less exactly the same columns as the non-history tables. But in this case, the remarks column, which you might use to indicate why you're making a particular update, is replaced by a column called the status column. And that indicates whether a profile was accepted or rejected when you issued the command, and information about the reason for any rejection. And the same applies to the profile attributes table. The status column indicates where a profile attribute, whether a profile attribute was accepted or rejected, and the reason for any rejection. So they provide good diagnostic information, and not just for now, but it gives you a good history of what's going on. So bear in mind, of course, that if you delete rows from DSN profile or from DSN profile attributes, they'll stay in the history tables unless you delete them. So there may be rows in the history tables that apply to profiles and profile attributes that have since been deleted. Okay, so let's talk a little bit about differentiating remote applications. And the big question is, how do you differentiate between the remote applications accessing a DB2 server? And the big move to distributed applications has made this much more difficult, because they all typically run with the plan name of distserv. In fact, they all run with the plan name of distserv and generic packages, NULLID. And on top of that, you typically get generic auth IDs being used at application server levels with those IDs and the privileges that those IDs inherit. Those are inherited by the calling application. And when you've got large middle tier servers, you've typically got a much wider variety of applications coming in. So that can make it a bit of a challenge differentiating between those remote applications. If you can manage to do that, you can exploit that in many different scenarios. And this really applies, as we'll see, when you're using the client information fields. But you can use that information for WLM workload classification, which is a very significant benefit. You can use it for internal chargeback. You can use it for a problem diagnosis, because that information is contained in trace records. You can use it for security. If you're exploiting trusted contexts and roles, you can use it for the resource limit facility, which you have to do that again via system monitoring profiles. And you can use that for monitoring and crawling threads and connections via system monitoring profiles, which was the initial use of system monitoring profiles. And of course, you can use that for different bind options for the RDA dynamic SQL applications, and especially for APPLCOMPAT. So let's talk about those client information fields. If you can identify applications by auth ID, role, location, and so on, then congratulations. I think you're probably amongst the few who can do that. The alternative for server-side configuration is to rely on the client information fields. Now, there are actually 6 client information fields, but only a subset of those can be used for setting special registers via system profiles. And those are client user ID, client workstation name, and client application name. Unfortunately, you can't use things like client account info and so on to do that. So in terms of setting those fields, you can set those in the application via Java APIs, via .NET and CLI set methods and so on. You can set those via data source properties, driver connection properties, and of course through DB2 special registers. Now, obviously, setting those through the application is not attractive. So it's much better to set those through data source properties and through driver connection properties. So again, you've got a bit of a problem here because it requires you to do some work at the client end. So initially setting those up can be a significant, and almost certainly will be a significant effort. A lot of administration time for setting those data source properties. But once you set them up with the required level of granularity, then the client information fields can be used for server-side configuration, for exploitation by system profiles. And of course, you can use them for multiple reasons. You don't have to use them for just for system monitoring profiles. You can use them in addition for WLM workload classification. So there's a big effort probably in setting them up, but the payback, if you can do that, is going to be massive. So let's just have a quick look at setting up system profile monitoring. So these are some example entries for some APPLCOMPAT profiles. Not all columns are shown, obviously. And really, these are just geared towards setting up the special registers so that we can use different null ID packages. And I've included the remarks table there because it's always a good idea to provide some documentation to identify why you've done why you've inserted a particular row. And the next thing is you can see that we've got 3 rows here, one for client user ID, one for client application name, and one for location with a domain name in it. And of course, the profile is enabled. And then we've got a matching row in the profile attributes table for setting the special register. And you can see that we've got a variety of different special register settings in there. You'll notice that attribute 2 and attribute 3 remain null. They should remain null if you're doing this. So just watch out if you're doing this, right? So in this case, if you specified the domain name, that will take precedence. So anybody coming in from that server 01, the application server 01, is going to pick up a package set called null ID v12r1 m100. So no matter if you match on client application name or client user ID, coming in is going to coming in from that server 01, that server 01 is going to take precedence. So you have to be very careful when you set these up. Okay, so just coming up to conclude, really. If you want granular control over APPLCOMPAT at the application or application program level, the best advice I can give you is to filter on the client application name, user ID, or workstation name, either coded in the application or set by a client-side configuration. And I guess one of the messages here is that client-side configuration, if you want to achieve this, is unavoidable. But if you're using system monitoring profiles, you only have to do it once. Now, if you're not already using those client information fields, then implementing them is almost certainly going to be a significant project in its own right. It's going to involve testing. But once you've set it up, it's got benefits not only for system profiles, but also for workload classification by WLM, for problem diagnosis, and so on. Now, the key thing about all of this is that if you're going to manage APPLCOMPAT for applications using the NULLID packages, you've got to choose the best strategy for your organization and set up a project to implement it. Otherwise, your applications are going to be limited to the lowest APPLCOMPAT level of all your applications. So what you could do, for example, is as you introduce new applications or modify existing ones, set up the client information fields when you're doing that and point them to the correct package set. So it doesn't have to be a big bang approach. What that will do, however, is will mean that you're going to have to do a lot more work. You're going to have to a lot more work to eventually move up all your applications to a new APPLCOMPAT level. But the alternative to setting up that project is to fix all compatibilities in all applications before you advance APPLCOMPAT. And that is not an attractive proposition in the kind of world which we live in today. So that's that. That's the presentation for now. Please submit your session feedback. For those of you who are using the little thing here, I forget what you call those things, what that's called, Rob.
I don't know.
QR codes.
QR codes, for those of you using QR codes. I hope that works for you. I will be uploading the presentation onto the site once we've finished. So cheers everybody, and thank you for that. And I hope you enjoy the rest of your day.
Well, thank you very much, Gareth and Rob. I don't know about the rest of the attendees, but I am so glad these sessions are being recorded, because there was a goldmine of information there. I'm going to have to go back because I can't remember everything. That was very useful. Thank you both. This was great, really good. Thank you everybody for attending. I don't think there are questions. I do have a question though. You were talking about fixing the last line, fixing your incompatibilities, and that's not necessarily a attractive proposition in these days. In your experience, how difficult, or first of all, how many incompatibilities have you come across in customer sites, and how difficult have they been to overcome?
Interesting question, Marcus, very interesting question. And the fact is that there aren't a great deal of incompatibilities. But the big thing is that you have to test every single application at a new APPLCOMPAT level. And for some people, that is a big challenge, not necessarily because technically it's difficult, but because of getting project funding to do it and getting the testing slots to do it is the challenge. It's technically not necessarily very difficult, but it's simply funding and getting testing slots. That's the biggest challenge there.
Right, of course. Yeah.
Yeah. That's the main challenge. But once you've done it, of course, then you're very happy.
Yeah. Fab. Well, thanks everyone, and remember, fill in your feedback forms. The next session, if I can have a look at my webpage. I don't know, what day is it? Where are we? APPLCOMPAT. So the next DB2 session is at 12 o'clock. And we've got Hong Tran. How does DB2Z transform your SQL query for better performance? So speak to you soon. Take care.
Thanks,
Cheers
everyone.
now.